Hi there, welcome back to the channel. Welcome to the fourth video in the restoration series of this SABA Meersburg W3. In this video, I'm going to handle or tackle the FM alignment, the FM-IF alignment. This is usually a little bit trickier than the AM-IF alignment, but it's certainly more interesting, it's more challenging. And what I decided to do is to follow the instructions pretty closely. Got to a point where I had to sort of deviate from what they tell us to do. But the interesting thing about this is that these IF transformers are a little bit more complex than the ones that you normally find on these tube radios. These guys have got 3 adjustments per transformer. You've got the primary, you've got the secondary, and then we've also got a coupling adjustment where you can change the amount of coupling between the 2 coils. You can gain or reduce the sensitivity depending on what your criteria are. But the point is, I try to follow the instructions. And in this particular case, you'll see why I normally say that it's important to know why you're doing something. That's why I did the Back to Basics series, so that you know why you are doing something. And by knowing why you're doing something, you can deviate from their recipe. And their recipe in this case didn't work for me. It wasn't working for me. But because you know what you're doing, you can try different tricks or different methods of achieving the same result. And that's what happens here. So if you want to see how I tackle this FM-IF alignment, stick around. I did a translation of the instructions. I've got that in English, so it should make it a lot easier for most of us. And if you enjoy this sort of thing, stick around, enjoy the video. But before I carry on, I want to thank PCBWay, the sponsors of this video. They're the company that I go to for all my PCBs. They've got some really incredible prices. Their turnaround time is really fast. And with all the boards I've ordered from them, any mistakes I've found were mine and not theirs. The quality is exceptional. But their services don't end there. I've also used the 3D printing services, and the result was far better than I could have imagined or achieved myself. They also offer CNC machining, sheet metal fabrication, and what a lot of you have been doing with the projects that I've shared on their share section is actually PCB assembly. So if you don't want to do it yourself, you order the board fully assembled for you. And I know that some of you have used this service and the results have been quite exceptional as well. Right now they're running the 11th anniversary badge design contest, and this is an opportunity for you to release your creative juices into the contest and grab yourself some very interesting prizes, both in cash and in coupons. So whether you're just looking for normal PCBs or assembly or any of the other list of services they offer, go to PCBWay.com. I'm sure you'll find something for your needs. Now we get to the FM alignment, and this is the part that scares a lot of people. And the reason is usually because this thing here is pretty scary. If you open this up, you'll find that things are pretty crammed in there. And the other thing you need to know is that everything is placed in the exact spot that it's supposed to be, and it's usually there for a reason. What happens is, because you're working with higher frequencies, I mean, we're working with the FM, right? At that frequency, the position of wires makes a difference. The proximity of components makes a difference. The orientation makes a difference. And so a lot of people that work on these radios are pretty fearful of this guy. I've got to tell you, I've opened a few of these up. My fear was pretty quickly surpassed because it's not really as bad as it seems. But if you can avoid opening that up, by all means, avoid it. You do not want to play in there unless you really have to. So when it comes to the alignment of the FM, whether it be the IF or the actual RF, you do most of that, you do all of it actually from the outside, which makes it a lot easier. You've got to be careful with things like the trimmers and the coils that can be stuck, and it's very, very easy to break one of those. So you've got to do it very carefully, but by all means, go ahead and try it. I mean, if you're going to do an adjustment, you can in fact reverse whatever you do, provided you're getting sound coming through, right? Things are working, you make an adjustment, it doesn't get better, it gets worse, you go back, okay? But what I'm going to do here is more focused on the IF alignment than the RF alignment. And the reason for that is that I've noticed that the actual RF alignment, the actual position of the stations in correspondence with what it says on the dial is very, very accurate. As I mentioned in the last video, I've got a station on 88 and I've got a station on 98 megahertz. They are very exact. And when I tested the two, they are pretty much spot on at this end and at that end. So I don't think I need to worry about the oscillator, the actual RF alignment of the oscillator. I may have to play with the RF alignment of the front end. I'll see if it makes any difference. But what I'm focusing primarily on is the IF alignment, the IF being 10.7 megahertz. And that one I know probably needs some work. And the reason I know that or suspect that is because I did take these cans off when I was looking for that crackle in the audio. And when you take these off, you're basically moving things around. And when you move things around, as I mentioned with regard to this guy, you can detune things. So the IF alignment is the first thing that I'm going to do, and it's done on these coils. In fact, it's done on that one there and that one there, and then there's another one inside here. But I'm going to follow it by the book, and what I've done is I've actually translated the alignment instructions for the FM just to make it easier. So we'll press FM. I haven't switched it on yet. Press FM and see what it is they tell us to do. And here's my translation, FM section alignment of the SABA W3. First thing I did is I took the plan that you get on the service manual, which gives us the positions we need to adjust. I mentioned with the IF alignment for the AM that we used these down here, 1, 2, 3, 4, 5, 6, 7, and so on. Well, with the FM IF alignment, we use these over here. So we've got 21, 22, 23, 24, 25, 26, and then 27, 28, 29. I think that's about it. I think that's all the IF alignment steps, but they do tell us precisely how to do that. And it starts with pressing the UK button, the FM button, select FM. We've done that. Then they tell us to connect a voltmeter with 10 volt full scale, impedance greater than 500 kilo ohms to the X and Y sockets. Now that means you connect a meter to this over here. This socket here is used for testing and alignment. That's between the X and Y. You're connecting a meter between that. And all you're doing here is really measuring across that capacitor, the discriminator cap. And we can see that. There's Y, it's ground. And X is this one over here that comes to here and it goes to that position on the capacitor. That's the discriminator cap, and the other side of the cap is ground. So this is that, and X is over there. If you didn't have this socket, you would go inside the radio and just put a voltmeter across that capacitor. And then they tell us to put a microammeter with 0 point in the middle to the X, Y, and Z or Z socket as shown in figure 1. What do they mean here? We're still across the capacitor, the X and Y, right? So you're basically measuring from there to a central point, but we're using two resistors in series there that join in the middle. So you're isolating the Y point by 200K, you're isolating the X point by 200K, and then you put one side of your microammeter there, and the other side of the microammeter goes to Z. Now again, Z on the socket is pretty easily identified. It's over here. That's your Z. So you are taking the ground point, raising it by 200K, taking the X point, which is that point on that capacitor, raising it by 200K, and then you're taking it from here. This here is actually where your signal comes out of. If you follow this over here, it goes through there, you're measuring there, it goes down, 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 and it is your FM audio, okay? So that's what you're doing. You're balancing, you're literally balancing this coil over here, number 23, by adjusting it till you get a balanced signal over here, 0. In other words, you're supposed to measure it to the point where it gets 0 reading between it and that joining of the two capacitors. So you want to get this adjusted so that you get 0 microamps. Now, you normally would have a meter that has 0 in the middle, and if it's negative, it would go left, and if it's positive, it would go right. I don't have a 0 center, so what I use is a normal micrometer that has a reverse button, so I can adjust it. For example, if it's positive, I'll adjust it till it goes to 0, and if I want to keep adjusting, it's going to go negative. So I flip the switch, and then it shows as positive. I'll show you when I do it. But I've actually got one of these fixtures done up already. The one I've got uses 100K resistors. I think it's perfectly fine. I've built it up with 2 crock clips for those 2 points there, and a little ring where I can connect the meter over here. And again, I will show you that. So you're ready to do your alignment because you've got your instructions as to where to measure. Now, you do these separately because they tell you to connect the voltmeter to X and Y, and then they tell you to connect this to X and Y. I normally don't put the two together at the same time, but let's see what they tell us to do. They say connect the 10.7 megahertz unmodulated generator with the output cable terminated to the grid of the mixer tube ECH81. So they're telling us to send the signal to the beginning of the IF chain. They are telling us to feed the signal into here, 10.7 megahertz, with no modulation, okay? Now what's going to happen is that it's going to get amplified and get sent out of here, and it goes across there, and it goes into there, through there. That coil there becomes the load to that anode of the tube. So it's getting produced across this coil over here, which is number 25. And you adjust 25, you have to peak 25, peak 26, and you've got the coupling between them. You can adjust the amount of coupling between these two. Got to remember that 24 is coupling, 25 is primary, 26 is secondary. We'll see where that comes into play next. Then of course it gets amplified by the IF amplifier. Then it comes to here, again across this coil over here, this transformer. And this transformer has again got a primary, it's got a secondary, and it's got the coupling. But this secondary is different to the others. Whereas the previous two, the first primary, first secondary, and this primary, you adjust it till you get a peak of voltage across this capacitor, in other words, a peak across XY. With this transformer here, with this coil, you adjust it to get a balanced current between the XY point and the Z with the microammeter. So this one is slightly special. We've got to be careful with that one. But let's see what they tell us to do and in what order to do it in. So here it is. You connect your signal generator to the grid of ECH81 exactly the same way as we did with the IF alignment for the AM. The difference is that the frequency now is 10.7 megahertz and it's unmodulated. And we have to align the two circuits of that transformer. That transformer is the one that has 21, 22, and 23. So that transformer is this guy over here. 21, 22, and 23. See that? So let's see what it looks like when we set it up, ready to start the alignment. Well, here's our signal generator set to 10.7 megahertz. I've got the amplitude at 2. I'm not sure what I'm going to need. At the moment, I've got my stepped attenuator at 0 dB. I can go attenuate more if I need to. I'm not sure how much I will need. I've got the signal connected to the grid of the ECH81 as they tell us to do. I've got the volume pretty high. And I want to send a modulated tone so that I can hear it. And there it is. What I've done is the modulation I've set to FM. I've given it a deviation of 25 kilohertz, sending I don't like 1 kilohertz. I don't know why. Let's give it 800 hertz tone. So for some reason, the 1 kilohertz resonates in my ears. Anyway, it is being modulated. And so what this is doing is sending a 10.7 megahertz with the tone on it, and I can get rid of the tone like that. The signal, the carrier, the 10.7 is still going through, but there's no tone. So how's this connected? Well, the signal is going into the grid of the ECH81 over there, and then I've got these two banana socket things here on that plug or that socket, the test socket, and I've got these two probes going to X and Y. And they are in turn going to my meter, which is set to DC volts. We're measuring a DC voltage and it's negative, so it's actually minus DC volts, but I could just flip those bananas across, reverse them, and I'd get positive. I've got it on the 10 volt range. If I put the modulation on, you can hear it through the speaker. Now, I don't know, I'm not sure just how strong that signal's supposed to be, but I've got a feeling it's got to be much stronger than that. They tell us at one point you've got to get this up to 10 volts. So I am at, what am I at? I'm at 2 volts. So what I'm going to do is I'm going to increase the amplitude of the signal. I won't go as far as 10 volts, but let's leave it there. That's 9 millivolts RMS coming in. I have not terminated. That's a 50 ohm signal generator. So I've not terminated the signal going into the ECH81, which means that 9 millivolts is neither here nor there. I'm just measuring what I'm getting at that voltage across that capacitor, and I'm using that as my reference. Okay, so I think we're about ready to see what it is they tell us to do. Well, the first thing they tell us to do is to adjust 21 counterclockwise. They say to the left till we make this subcritical. So I'm going to be doing the following. I'm going to be adjusting 21, and then they tell us to adjust 22 for a maximum on the voltmeter. So reduce the coupling with that one and peak with that one, and then we'll come back and see how we do that guy over there. Let's have a look at the meter in the meantime. So if I make this subcritical, I don't know, they don't tell us how much, but I do see that it does go down because I'm reducing the the coupling. I think I've done as much as I can actually. And now I'm going to adjust 22 till I get a peak on the meter. No, wrong way. It was pretty much peaked. That is a peak, that's all. Not very exciting, is it? So that's it, that's 22 done. Now we've got to do 23, and that's where they tell us to use the microammeter. So I've got one lead of the meter connected to Z, and now I take these two guys. This is what I've created with the two resistors. I've switched everything off because you can very easily touch the mains over here. You do not want to do that. It doesn't affect your alignment, except perhaps you won't be able to finish it because you could be dead. So we'll put that across those two guys. Okay, and now I connect the other lead of the multimeter to that joint in the middle there, and let's see where this goes to. I've got the meter set to 100 microamps, and this meter is great. It goes down to 10 microamps, but it's slightly negative, so I'm going to flip the polarity switch. I'll put it to 10 microamps, and now I'm going to adjust 23. I want to get that at 0. Nope, that's the wrong way. Should go down, but I want to go down that way. And if I flip the polarity, I should get, and keep turning the same direction, I should get a peak there as well. So I want to go to the middle there, right there. Oh, this is very, very sensitive. And I think that's near as damn it perfectly aligned. And if I put the tone on, I should get a very good quality tone. Now, why do I say that? Put that off. The tone, this is where the detection is being done perfectly. So the tone that's coming through the speaker is being perfectly detected on that 10.7 megahertz carrier. And this is another way of doing this alignment. You can put the output on a scope and adjust that 23 to get the perfect sine wave, or the best sine wave possible, which means you've got the least distortion. And that tells us that we've got a good alignment. And that's it. We've got that transformer done. We've done 21, decoupling, or loosening the coupling, 22, peaking, 23, the balancing. Now, we're going to have to come back to 21, but they tell us to do that a little bit late on the instructions because we've got something else to do first. And that is align this transformer here. Now remember, this side here was for the AM. This is the first IF transformer for the FM. And we've got 24, 25, 26. Let's see what they tell us to do. Here we are. IF alignment 10.7 megahertz, so the second filter behind the mixer. So this is, yeah, it's exactly the same as the other one. Set the coupling of the two circuits with position 24 to subcritical. 24 being the bottom one there. Then adjust both circuits position 25 and 26 for maximum on the voltmeter, and adjust the coupling to critical, which is the maximum on the voltmeter. So loosen that, the coupling to subcritical, adjust 25 and 26 to a peak, and then go to 24 and adjust that to a peak. So let's get that done and see how we get along. Right, so I'm going to loosen the coupling with that one and then peak those two. I've removed the wax already. Let's look at the meter. I've actually dropped the amplitude a bit. I think it was a little bit too hot. I think that 10 volts that it's supposed to show us is when we're trying to do the AM rejection, which we'll get to next. Let me go to 24 and drop it. I think that should be good enough. And now I'm going to peak the other two, see how we get along. Got a little bit out of that. That is the peak. That was 25, and now let me go to 26. That seems to be it. Not much to it. Now let me do the peaking of the coupling again to critical, to a max. And it's That is the peak. Okay, that's it. That one's done. Now we're actually going to go back to that, the first one we aligned, and it says set the signal generator to 10.7 megahertz with 30% AM modulation. Now remember, we are trying to decode FM, so we would use FM modulation, but one of the characteristics of these circuits is that it does good AM rejection. Why does it do that? Well, the whole point is that if you're receiving an FM signal, you don't want the loudness or the strength of the signal to be affected by the actual amplitude modulation that signal might suffer by being bounced around, or that sort of thing. So you only want to detect the FM modulation, not any AM change. So what they do is they tell us to set it at AM and then adjust the coupling. Remember, we loosened 21, adjust it, tighten it, until the audio voltage at the output terminals reaches a minimum. In other words, maximum AM rejection. And the voltage at terminals XY should be 10 volts. This means that you have to really make that amplitude of the carrier quite high in order to hear that. So this is where that 10 volts comes in. And then they tell us to correct the zero crossing again with a microammeter. Okay, let me do this stage and see what we get. Right, what I've got the 10.7 coming in with a tone, but it's FM modulated, so you can hear it, right? Putting the volume up. It's pretty loud. Now let me change this to AM modulation. You can still hear it. So it's AM modulation, depth of 30%, and we can sort of hear it. And now what I'm going to do, I need to increase that amplitude. Let me show you the meter. I'll be adjusting 21 there. Okay, I've lowered the volume a bit and I've increased the carrier strength, the strength of that signal that's carrying this AM modulated tone, till I get close to 10 volts on the meter reading the voltage across that discriminator cap. So now I'm going to play with the volume. I'm going to put the volume up and I'm going to start increasing the coupling of 21 till that drops. And it is indeed dropping. I don't know if you can hear it well with the microphone, but that's dropping. And what I can see is that that's going up because I'm increasing the coupling. So I'm going to reduce it a bit more. I don't want it to go above 10 volts. And I'm going back to 21. And now it's getting louder to my ears again. So I think the minimum would be there. Now, I could put a voltmeter, an AC voltmeter across the speaker, but I'm doing it by ear. I can discern quite easily where the minimum is, and that is it. Let me turn this off because it is annoying. Now remember, we're still hearing some AM modulation over there, but this thing is such a strong signal that, it's not going to eliminate the AM. It's not going to reject the AM completely, which is fine. So I tightened that coupling there, and I have increased or maximized the AM rejection. I now need to remove these, put the two resistors in place, put the microammeter in place, and adjust 23 again till I get the zero crossing. I've done that. I won't show you that again. I'll just do it off camera. And then we can carry on. Okay, this is where I'm going to deviate a little bit from the instructions because I've actually tried this and I can't get it to work. We've done that. Now this is F. It says, connect 10.7 megahertz unmodulated generator to the dipole antenna sockets. So right at the antenna. And then you align the two circuits in the FM module, set the coupling of two circuits with position 27 to subcritical, and then peak 28, 29, and then peak with 27. Where are these guys? Well, this is them here. You see they're on the actual module, which is why I've got the radio on its, with the side up, with the back up. And we've got 27, 28, 29. So we have to decouple or loosen the coupling with 27, and then we peak 28, 29. Now, what they tell us to do is to feed the signal into the dipole. I've tried that. I've either got to have a very, very strong signal. I think there's some kind of, there must be some kind of IF rejection at the front, which makes this require a very, very, very strong signal. I'm a bit loath to do that. So I decided to do my usual thing. I'll go the other way. I'm going to lightly couple to the to the mixer tube, which is the EC92, I think it is. Yeah, this one over here. I'll show you how I do it. I couple the signal to here, 10.7 megahertz, onto that tube around the outside. I don't actually touch anything in here. And what we're going to adjust is, where is it? This one here, 27 is the coupling, 28 and 29. Now, by doing that, I'm actually forcing the 10.7 megahertz to go through the tube, and I can then adjust this for a peak. And it should give us the same effect, because what they're trying to tell us is that we're supposed to feed it in here. Now, my feeling or my belief is that by feeding the signal in here, this is expecting, 87.5 to 102 whatever megahertz. When it sees 10.7 megahertz, for some reason, it just doesn't get through. Or to get through, it has to be incredibly high level or high amplitude. So I'm not too comfortable with that. So let me show you how I do this, and we'll try it. All right, back on its feet. The antenna is connected to the external dipole, and see how we are. This is a station here on, what is it, 93 or 92? This one, which I normally receive very, very poorly. I can't play music. This here I normally don't receive well at all. This is a strong station that I get. Perfect. This one is one that I normally receive pretty weakly. Sounds amazing. You go to the other end. There are a couple on the other end that I get very well. This is amazing. This one I normally get with a lot of static. It's coming through very clearly. Wow. 101.6. This thing is receiving exceptionally well. So well, in fact, that I'm not going to mess with the front end alignment of this thing. You can adjust it, get a peak for the antenna circuits. You can adjust the oscillator, but I don't need to. I'm getting perfect 88 there, perfect 98 here. So I'm not going to adjust that, but I thought of maybe peaking the antenna coils, but I'm not going to mess with that. I do not want to mess with that. This is absolutely amazing. In fact, I'm going to start listening to it now. Just leave it playing, but I can't play music for you, unfortunately. So that is where I'm going to leave you today, because I do have quite a lot to do still. I want to do the cabinet, and the cabinet's going to be a bit of a challenge. I'm still not sure how I'm going to resolve some of those issues with the veneer that's falling off and that trim that I need to replace. I haven't even given it any thought. And then, of course, I want to add the Bluetooth. So I think there's one more video in this series. It'll be the cabinet and the Bluetooth and testing and that sort of thing. So that's something that's going to come up very soon as I've got that done. So for now, I'm going to leave you. Thank you for your company. I hope you've enjoyed that. If you have, do click like, share, subscribe, and all that jazz. And if you want to support the channel, you can do so on Patreon and PayPal. Links are in the description below. Once again, thanks for watching. Bye for now. And most of all, stay sane.